still haven't come up with a reason why they didn't smelt iron. One interesting aspect of ancient Egyptian technological history is that Egypt never had an Iron Age.
Hard stop. There was no Iron Age in Egypt, at least not until after they were conquered. But if they didn't have an Iron Age, what kind of age did Egypt have? And the answer was they had a Bronze Age. And in an electric universe interpretation of these sites, what's the primary difference between iron and bronze? And the answer is that iron is a ferromagnetic element. It attracts magnetism. It is affected by magnetic fields. But bronze, bronze is diamagnetic. It isn't attracted to anything in a strong magnetic way. Why didn't Egypt have an Iron Age? The answer is right in front of us in this short video. Don't forget to click that like, share, and subscribe button. Don't forget to say hello to Blue. And as we begin, don't forget to share your thoughts with Dr. Miano. You see, like the magnetic difference between iron and bronze, the key difference between Dr. Stinky McDougal and Dr. David Miano is that Dr. McDougal believes that the Egyptians were aware of and harnessing the power of magnetism. Now, when we call it the Nile Delta, we should take that quite literally, that it is a delta as in a triangle. And to get there, we need to turn the entire map upside down so that we are looking at the delta of the Nile in its proper context. Now, anytime you look at a delta Y across the planet, you're always going to have a primary node to the delta. And that primary node is the Great Pyramid structure. It is the Great Pyramid, which itself, as you may know, I'm sure, has on it 8 delta structures. There are 8 triangles. Now, this is just the beginning of the entire structure, but the reason that the pyramids are laid out in a Fibonacci sequence is because their purpose is to draw the electromagnetic connection with the sun directly onto the site. And by doing that, they reestablish the natural delta Y that was created during the apocalypse. And that delta Y that forms over the delta of the Nile was done to increase the agricultural output of the Nile region, of the Nile Delta region. Well, Dr. Miano doesn't.
I'm not talking about wildly speculative stuff like ancient power plants, acoustic levitation, alien genetic manipulation, or any of the other pseudoscientific ideas. I mean actual peer-reviewed scholarship that reveals lost technical ingenuity we never fully appreciated before. Real ancient engineering genius that was buried under the soil, or in some cases, under centuries of misunderstanding.
Dr. McDougal agrees with Dr. Miano that centuries of archaeological misunderstanding have occurred in the past.
Dr. McDougal also believes that several continue to persist, such as ignoring the evidence for electromagnetism in antiquity.
Yep, peer review is meaningless because few, if any, of the reviewers have knowledge of the principles of electromagnetism, the fundamental building blocks of the universe.
The first step to true knowledge is admitting you know nothing, not everything.
Hey, Socrates! Nice reference!
Right?
As best modern archaeology can tell, the Egyptians operated with bronze long before and long after virtually every other society. What quality of bronze kept the Egyptians using it for so long? Was it prettier? Was it lighter? Were the raw ingredients more abundant? What quality of bronze served the Egyptians better than iron in an age where iron served virtually all the other kingdoms? What we are going to find is that iron wasn't a very practical metal inside the kingdom. Let's begin with what Dr. Miano means when he says there was no Iron Age in Egypt, because it is the first recognized prohibition within the kingdom.
In archaeology, the term Iron Age historically has not been used to refer to the first appearance of iron objects. It's been commonly defined by a structural transformation, when in a society iron ore is routinely smelted. Iron tools become common in everyday life, and iron replaces bronze as the dominant utilitarian metal across that society.
Hard stop. What Dr. Miano means when he says that there was no Iron Age in Egypt is that the process of smelting was never done within the kingdom. Why would you not choose to smelt iron inside of the walls of the Egyptian kingdom? Why would you not want to smelt iron near the Great Pyramid? Smelting is such an interesting process, and we're going to look at it in the context of what if there were a high energy magnetic field present in the area? What would that do to the iron? In the end, it's all about electrons, which in an electrical circuit come from the ground. And in our example today, the electrons are coming from the delta ground itself under the Y magnetic induced field. As current from the sun flows down, the grounding effect of the Earth moves electrons of the negative charge from the core upwards. Current, charge. All of this is normal, proven science.
Or in some cases, under centuries of misunderstanding.
This is an example of what Dr. Miano calls lost technical ingenuity. We don't understand that they knew what they were doing with this machine. The Nile Delta Y is a way to store electrical charge overhead in a field of induction, which then acted like a suction cup of electrons from the ground, which then flowed at a higher rate, thus causing the crops to grow bigger and bigger. It's all about exposure to the electron. What we will explore next is this effect of current and charge exchange on iron smelting within the canopy of the delta Y structure. Iron ore, often hematite or other oxides, is mined, crushed, and roasted to remove moisture. During this phase, the material is considered diamagnetic or slightly magnetic depending on the purity. Charcoal is made from wood and becomes the essential fuel and source of carbon monoxide for reduction. They alternate the charcoal and the crushed iron ore in layers in what is called a bloomery furnace, a simple clay stone or pit-lined shaft that was built or readied often with tueries, air pipes for bellows, to create the high temperatures needed to smelt the iron into what is called a bloom. What archaeologists have never found, what archaeologists describe as a lack of an Iron Age, is one of these bloomer furnaces in Egypt prior to being conquered from outside. Now I asked Grok, what steps would it take to create a permanent magnet during smelting, and the answer is very illustrative of the distinction. You see, if you smelted iron inside the delta Y structure, it would result in this permanent magnetization. Now, according to Grok, ancient blacksmiths occasionally noticed this effect accidentally when working iron north-south aligned to the Earth's field. A deliberately strong magnetic field during cooling makes it dramatically stronger. Permanent magnetization is created in the cooling and forging stage, right after or as part of the smelting, through thermoremnant magnetization, TRM. Here's exactly what has to happen step by step. 1, the iron has to be heated above its Curie temperature, so it has to go above 770 degrees Celsius or 1418 degrees Fahrenheit. At this point, thermal energy completely randomizes all magnetic domains. the iron temporarily loses all ferromagnetism and behaves like a normal paramagnetic material. It has no effect from the magnetic fields. 2. It must cool slowly through the Curie temperature while sitting inside an external magnetic field. Now, all iron cools within the Earth's weak magnetic field. But what if we applied a stronger one, such as the delta Y, over the top? This would be the magnetic field that would influence the iron during cooling. As the temperature drops below the Curie point, magnetic domains begin to form and preferentially align with the direction of the external field of the delta Y. In Egypt, the powerful external field was the Y field of inductance that formed here, here, and here. Anything you would have smelted inside of this magnetic field would have aligned to the magnetic field of the delta Y itself. Now finally, the bloom must be hammered, that is forged while it is still hot and cooling. Mechanical working creates dislocations and grain boundaries in the crystal structure that quote-unquote pin the newly aligned domains in place. This locking prevents them from flipping back to random orientations once the external field is removed. So in short, any iron you would smelt within the Egyptian kingdom would have a degree of permanent magnetism when created inside the delta Y's influence. And if you struck the iron bloom at all right out of the furnace, you would increase and cement the permanent magnetism created by the delta Y. To make things even better, the strength of the magnetism would be greatest if the iron of that bloom stayed inside the magnetic field of the delta Y, making swords of iron useless within the kingdom, since they would be magnetically aligned to the delta Y, and upon impact with another iron sword, would experience the attractive forces of magnetism. You would be challenged to strike again. The final wrought iron, or early steel, would have retained strong, permanent magnetism. It would have become a natural magnet, a lodestone type of behavior. And in Egypt, they were in the middle of a magnetic field. So what Dr. Miano is describing here is called evidence of absence. Not an absence of evidence, evidence of absence, which is to say there is an absence of any evidence that they smelted within the Egyptian kingdom. And it's important that we look at it that way rather than saying, did they ever achieve the technological skill set to work with iron or not? Because the answer is yeah, they knew what iron was from a very early stage. And we're going to explore that nugget next with Dr. Miano. Now, what's really great about this next piece is that Dr. Miano gets the naming convention of iron completely right.
Iron appears to have been referred to under the broader term bia, a word that could denote metal more generally, with its precise reference determined by context. From the late 18th dynasty, roughly around 1300 BCE, Egyptian texts begin using a new term for iron, bia enpet. Translated literally, it means iron from the sky. Or perhaps there was a belief that all iron originally came from the sky, even the iron that is now on the ground. Whatever the case, it would seem that the defining feature of iron for the Egyptians was its origin, and not its manner of production.
The Egyptians' defining feature in naming iron was origin?
Yeah. Iron from the sky.
Iron from the sky?
Iron from the frickin' sky, dude.
Miano said that?
Check it out again.
Bia enpet. Translated literally, it means iron from the sky.
I agree with these guys. It's an exceptionally interesting linguistic note. All iron comes from the sky. That's the description that we need to match.
Okay, time to go. He'll never know we were here.
Did you take out the Itoprobe?
During the global apocalypse, The planet Venus came in close contact with the Earth, leaving an impact rim we call the Himalayan mountain chain. This ball doesn't fit the arc perfectly by chance. It fits because the thing that formed the Himalayan mountains was the round planet Venus. The associated scar on Venus is called the Artemis Chasm, and the material to form the Himalayan mountains on the Earth came from the Artemis Chasm on Venus. Chasm, mountains. This is why there are seashells on top of Mount Everest. Material from the oceans of Venus fell to the Earth, and we can follow those electrical patterns to find our planet in the current state that it is today. During this first phase, the current running through the Earth expanded and transmuted the ground to produce the elemental mix we see in our crust today. Every square inch of the planet's crust was affected. The gold in San Francisco was transmuted during the apocalypse, the silver in South America was transmuted during the apocalypse, and all the world's metals are where they are because of the apocalypse. Thus, the same general name. Have you ever looked at the location of the largest rare earth deposits on the planet? 5 of the top 6 are adjacent to the impact crater, and the 6th one is the antipode to the impact. Gold star, Dr. Miano. All iron comes from the sky. And next, we will see that all iron from the sky that scientists call meteoric is actually apocalyptic.
Hey, some of the oldest iron objects ever discovered come from Egypt. In pre-dynastic burials at Gerza, dated to around 3200 BCE, archaeologists found small tubular beads made of iron. For decades, there was debate over whether these objects were genuinely ancient or intrusive. But now we know. Scientific analysis has shown that the Gerza beads are made from meteoritic iron. They contain elevated nickel and cobalt levels characteristic of iron meteorites. And their microstructure shows that the metal was hammered, not smelted. Thin sheets of iron were worked cold and then rolled into tubes.
So here we are at the really exciting end. What we're looking at in these beads are a remnant memento of the apocalypse. At the very end of the apocalypse, there was an electrical discharge. It was the pressure release that was sent into Venus. It's why Venus's atmosphere is so pressurized. But in that discharge, it transmuted some of the material that was falling from Venus to Earth, and it transmuted it into iron. And the survivors would have probably seen this iron, what Miano has described as a meteor. They would have seen this iron falling after the final discharge event. And when you see these things, right, and they mean something to you because you experienced the event itself, you hammer it down, you put it into beads, and you wear it at very special occasions. Probably occasions where you memorialized their origin. Iron from the sky. Nobody's Electric Universe Archaeology touches Dr. Stinky McDougal. Don't forget to click that like, share, and subscribe button. Don't forget to leave me your thoughts in the comments down below. Please don't forget to tell Dr. Miano your thoughts on this video. And peace out.
Do you have the anal probe?
No, I said no anal probes. We were very clear about this. We're very clear. First of all, I know it's used.
What did you just do?